Hello, AP Physics 1, it's Mr. Ng, and I wanted to take some time to clarify your Tippers assignment. So this was the first one in your kinematics set, and basically you're tasked with ranking the accelerations of these spheres. So between each sphere is the same segment of time, could just assume it's like 1 second. And if you notice, this thing went pretty fast to slower and slower. So this thing had a negative acceleration. It's slowing down. This one is going faster and faster. Look, right? These things are traveling farther in 1 second. So let's just call this a positive acceleration. This thing is going steady, so 0 acceleration, and then another positive acceleration. So if this question asks to just rank the accelerations, right? If we ignored the word magnitude, then I would probably do this as B is equal to D, which is greater than C, which is greater than A, because A has a negative acceleration. Unfortunately, this is the advice I gave you yesterday, but I forgot about this word magnitude. So because the word magnitude is there, we could just take the absolute values of it. So instead, let's just consider the magnitude of this acceleration. This book said that A is slightly smaller than B and D. So the actual answer key, put it as B is equal to D, is now greater than A and then C. And C had to be the smallest because it's 0. So to clarify, if it just wanted the acceleration, then we would need to consider the sign. In this case, here I'll erase this. This one had a negative acceleration, right? Oops. But because the word magnitude is here, then we just consider the absolute value. So it rearranges the order just a little bit. The most important part here is not to get the right answer, but that you understand that. So hopefully somewhere in your homework assignment, if you clarify that, I would greatly appreciate that. So this question is not about acceleration. And I want to clarify that sometimes we go through these problems and we just look for visual cues, and then we start doing the same kind of pattern thinking. But this one is not even asking for acceleration. Instead, it wants you to rank the average speed of the last time interval. So this is pretty easy. We're just looking for the largest distance, because imagine each of these intervals is just 1 second. So this traveled a larger distance. I'm going to draw a big D here over a segment of time, versus this one, right, like a small distance over the same segment of time, right? So obviously A has a larger speed than B. So here, by the looks of it, A and D are the biggest, and then B is kind of the second biggest, and C is the smallest, right? I'm just looking at the difference in, I'm just looking at this little space here, right? C is real tiny. Hello, look at this little man. Okay, so let's go with A is equal to D, which is then greater than B, and C is the smallest one. Shouldn't have any confusion there. So here's number 3 in your tipper set. These are all position versus time graphs, and this problem wants you to find displacements. So first and foremost, you need to verify the type of chart you're looking at. And this is a displacement graph. This is a position over time graph. Oftentimes we see these little lines, and some kids will make the mistake of just assuming that this is a velocity versus time graph, especially with like a little triangle like this, but just confirm by looking at the axes. So here, let's go one at a time. This thing started at a position of 6, ended at a position of 6, so it didn't really change, so it had a displacement of 0. This thing started at a position of 2 and then ended up at a position of 6, so it gained 4. If you need a formula there, displacement, delta D, is equal to the final position minus the initial position. So in this case, it would be 6 minus 2. Here, it started out at 8 and ended up at 0, so this is negative 8. And then finally, it went from 0 to 0, so this one is also at 0. So if I was just gonna rank the displacements without this word magnitude here, if I just rank the words, just rank the displacements, it would be B is then greater than A and D, which are equal to each other, which is then greater than C, because C is negative. However, the word magnitude is here. Because the word magnitude is there, we're just going to consider the absolute values. So really, the answer, at least out of the book, is it's going to be C is the largest, because we could just do the absolute value of -8. So this is going to be C is greater than B is greater than A, which is equal to D, because they're both 0. Okay, let's look at the very last question in your tippers. So here, as if you notice, we are dealing with velocity over time graphs. And the question wants us to figure out which of these two cases presents the larger displacements. So just by looking at it, I can tell that these two areas, right, that's the procedure for displacement when you have a velocity over time graph. You find the area under the curve, and these two areas are the same. So our displacement here will be 0, right? A negative value and a positive value that are equal to each other, it cancels out to 0. And here we have a larger negative and a smaller positive. So we have some sort of negative displacement. At least we have some value. So if this was just asking for displacement, then I would say that case A is bigger. But it's asking for the magnitude of displacement. If it wants the magnitude of displacement, then we do absolute values, and any value will be greater than 0. So the actual answer out of the book is actually case B, because it wants the magnitude and not just displacements. So long story short, I forgot to think about magnitude when I was walking around and helping you guys yesterday. And once the word magnitude is there, you just consider the absolute value. You just consider, you don't consider the signs. Thank you very much for watching. You guys are doing a great job. Good job on that last quiz. Thank you.